Let's talk about problem 1. And we know that the probability of x equals k equals p multiply k multiply p to the power k minus 1, and k from 1 to positive infinity. And question A, find B so that probability of x equals k presents a probability mass function. And we know that the sum of probability k from 1 to infinity, the sum of the probability equals 1. So we can get b multiply k multiply p k minus 1 equals 1. And then we should count this form. And through the observation, we can get this. K multiply p to the power k minus 1 is the derivation of p to the power k. So for this, we know the series expansion, the p to the minus k, the sum of p to the minus k equals 1 minus p over 1. We get this. So this form equals b minus t to the power k's derivation equals b like this. It equals equals 1. So we can get b equals 1 minus p to the power 2. And question 2, find the expect of x. And we should to write the form of the expect first. Expect x equals the sum of k minus p x equals k, right? So it equals b multiply the sum of k to the power 2 minus p to the power k, to the p to the power of k minus 1. So we should now to count this form, and we can find that k to the power of 2 multiply p to the power k minus 1 equals k minus multiply p to the power k derivation. So we should find this form And we know that from the probability A, we know that the sum of k multiply p to the power k minus 1 equals 1 minus p to the power 2 over 1. So we can know that k multiply p to the power k equals 1 minus p to the power 2 over p. That means we multiply p on both sides. So this derivation is this derivation. So the expect of x equals b multiply p 1 minus p to the power 2 over p's derivation. And we know that b equals 1 minus p to the power 2 on the problem A, and this form equals 1 minus p to the power 3 over 1 plus p. This equals 1 minus p over 1 plus p. So the expect of x equals this. And for problem C, we should find the expect of x to the power 2. And like the problem B, let us write the expect first. The expect of x to the power 2 equals the sum of k to the power 2 multiply p x equals k. And from the problem B, we know that this equals b minus the sum of equal k to the power 2 equals to the power 3 equals p to the power k minus 1. So, and from the problem B, we know that sum of k to the power 2 multiply p to the power k minus 1 equals 1 minus p to the power 3 over 1 plus b. So like problem B, we know that the sum of k to the power 2 minus p to the power k equals 1 plus p multiply p. That's we multiply p on both sides, and we can see this form is the derivation of this form. So the expect of x to the power 2 equals b multiply 1 minus p to the power 3 over 1 plus p multiply p. This forms derivation. So that equals b equals 1 minus p to the power 2, and this equals 1 minus p to the power 4 over 1 minus 4p plus 1 plus 4p plus p to the power 2, and it equals 1 minus p to the power 2 over 1 minus 4p plus p to the power 2. And the expect of x to the power 2 equals this form. And this is problem C. And problem D. It asks us to find the expect of x to the power 2 minus expect of x to the power 2. So we use the result of problem C. Minus the result of problem B. That's very easy. That equals 1 plus 4p plus p to the power 2 minus 1 minus 2p minus p to the power 2. It equals 1 minus p to the power 2 over 2p. Problem E. Problem E. P equals 3 over 1, and we should find the probability mass function p x equals k on the condition of this, and we can write this equation first. It equals p x equals k, and p x from 2 to 5. Yes, and it equals p x equals k, and x from 2 to 5. K from 2 to 5. P x doing x equals k. So this one is the probability of x equals k. It equals 9 over 4 multiply k multiply 3 over 1 to the power k minus 1. And this is a sum. The sum of k from 2 to 5, 9 over 4 minus k minus 3 over 1 to the power of k minus 1. And we can get this form. It equals 0.5377 over 1 multiply 9 over 4 multiply k multiply 3 over 1 to the power of k minus 1. That's the result of this form.